What's up guys, it's Nitin from Ascend to Second here, and today we will be discussing what expected value means and why we sometimes confuse it with other things, such as true values and what the actual answer is. So let's consider a die. So a die has 6 sides. It has 1, 2, 3, 4, 5, 6. Each having about an equal probability if you consider it a fair die. Sometimes you can have a weighted die that has different probabilities on different sides, depending on how it's cut and sliced and how heavy each side is. But let's just consider a standard die fair. So that means each side, 1 through 6, has probability of 1/6, 1/6, and so on. So they all have 1/6 probability. How do you find the expected value, or in this case, the average of that die? And what does that actually mean? And how we can use that in our benefit? So, expected value means you take, so expected value notation is E of x, if we just consider our variable have function x, of whatever the value is times the probability of that value. So if sometimes you can have a die that has 1 on each side. So the expected value of that die would just be 1, since everything is just 1, right? And so in this case, each side has a different value. That's why we need to consider each side's value. So 1 times 1/6 plus 2 times 1/6 plus 3 times 1/6, and so on. So we just do that for each side, multiply it out. The easier way of just doing this would be add all of the sides, add all of them, and then multiply by 1/6. In this case, we get 3.5. Now, you'll be like, Nitin, what does that even mean? How do I get a 3.5 expected value if that's not even on my die? That would be a very good question, and here's the answer. So what 3.5 actually means is that you have an equal chance of getting 4, 5, and 6, or 1, 2, and 3. It's exactly in the middle, and you can get probabilities. Since they're all equal, you can expect that type of distribution. So I wouldn't say put all your eggs in one basket on 3, because they all have an equal chance. They all have a 1/6 chance. So we can't explicitly say this is the expected value, but we can say we expect 3.5, even though it's theoretically impossible to roll a 3.5. Now, how do we use this to our advantage? Well, we can use multiple dies. When we roll a die, we can get more combinations, and more combinations means more things are possible. And so if we roll a die and we say I have 2 dice, each side is independent from one another, and each die is independent from one another. So that means if I roll a 5 on one die, that doesn't influence the roll on the other die. That means I can get a 1 through 6 on the other die without affecting that. So let's say I get a 1 on the first die and a 1 on the second die. That's 1/6 times 1/6. That's the probability. There's only one way of getting 2 1s. There's 1 out of 36 chance. To roll a 7, you'll need to get a 1 or a 6, a 2 or a 5, a 3 and a 4, and you can get that 12 different ways. And so that's more of a chance. That's more of a probability. And you can calculate the expected value of that to get that in your favor. So learning things fundamentally first can help you apply them in a more in-depth view to give you a better analysis of what things mean. So this doesn't make sense. But if I have 2 dies, that just means they're equal. That means I can just do 2 times this probability of E of x, which means the expected value of 2 dice now is just 7. And now that helps me, because I know I have a better chance of rolling a 7 than any other number that I can get. So, like I said before, rolling a 2 is much more harder than rolling a 7. That means proportionally 6 and 8 would be equal, and so on. So it's a normal distribution where 7 is the peak, since it's the mean, it's in the middle. And everything as you go outwards is harder to get. And that's the whole premise of finding expected values using variances and standard deviations to find how things move and react and how they are evaluated and how they just work. And this is how dice works, fair dice. And we're not even in the realm of weighted dice. And if that's something that interests you, let me know down in the comments. And if any other help you need, just let me know. All my links are in the description. I charge $0.01 a second. And that's all I got today. So, peace.